Welcome to Chapter 8, Part 1, Recursion. The Part 1 is actually kind of a misleading because we're not doing Part 2. But anyway, we're doing recursion and we're skipping the second part of Chapter 8. So we've been dealing with some repetitions, some loop statements, some while statements, and sometimes we don't know exactly how many times we want a block of instructions to repeat. All we know is that repetition is needed. So some options that we've seen is we could use while, and you all have been practicing that, or the other option we can use is called recursion, and that's what we're going to be doing during this session. So, like I said, so far the pieces we've been using to create a program are identified by these special things. Do in order, do together, if else loop. You found them all on the bottom part of the Alice screen. But recursion is not something that you can find special words for. It's actually part of the programming language. It's something that you do that causes indefinite loops. So the formal definition is that a method or a function calls itself, and that's pretty important. Okay, so here's our example, and you're going to download it in a second. You've got just a regular race, horse race. Maybe you've seen this if you've gone to a carnival where you pay money and you bet on which horse is going to win, and if you're right, then you get a teddy bear or something like that. So we're going to play this game, and the deal is that one horse is randomly selected to move forward. That one runs straight ahead to the finish line. This is important. A horse is a winner if it gets to the finish line before any other horse. When one horse wins, the game ends. So that's actually a more complicated program than you might think. Let's take a look at the storyboard. So if one of the horses has won, we want the winner to say, "I won." Otherwise, randomly choose another horse and move it forward a small amount. So the idea is that these three horses are each going to move forward a small amount. First one, then another, etc. Do everything again. Well, there's a lot in here. You can see an if-else. You can see that the winner, this is a method, right? The winner says, "I won." Another horse moves forward. That's going to be a method. But how do you know which one has won? You're going to need to ask yourself a question. In other words, there's going to be a function involved. So the do everything again part, that means the entire method, this entire method called race, is going to be repeated. And this is going to happen until somebody has won. As soon as somebody's won, then the game is over. So hopefully that makes some sense. Again, we're using recursion. So let's take a look at the stepwise refinement of the storyboard. Within the method race, we've got to ask ourselves, is the game over? And that's the if-else right there. We've got to ask ourselves, we've got to write a method to move the random horse forward, and the choice of horse is what's random. And then also we need to be asking the question, which horse won? So what I want you to do first is go to our haiku page and download, it's under Demos, Chapter 8. I want you to download, I don't know why it says V2, sorry, these two files. You're going to play this one first. So if you just want to download this one right now, this is great. Go ahead and save it as an A2W file and play it. And I want you to play it a few times. I want you to run it a lot. Go ahead and run it 10 times and track your results. And then you're going to come back and tell us what your results are. Well, you're going to think in your head. I'm going to talk about it. So go ahead and pause the program, download that first version only, play it, I don't know, 10 times, and come back with your results. See you when you get back. Okay, welcome back. So were your results surprising? You should have seen, you thought, that each horse ran or won approximately a third of the time, right? 3 horses, everybody should get a fair shot. But is that what happened? If not, why not? Well, it has to do with the code. So, believe it or not, it has to do with the probability percentage. So this is what I wanted you to do now. Oh, sorry, we're going to talk about something. Right. You had a conditional expression in there to determine when the game is over. And in this case, the game is over when one of the horses was within 0.5 meters of the finish line. That 0.5 meters is because it's measured from the horse's tummy, not from the horse's nose. If it had been from the horse's nose, then you wouldn't have any distance at all, but they use the center of mass. Also, hopefully what you saw were some random numbers, and they were supposed to introduce an element of chance, but there's something a little bit screwed up with that 1/3 thing. So, okay, here we go now. Go ahead and download the second file, and I want you to run that one 10 times and see what you can find. So pause now, download, play 10 times and see if it's any better, and then go ahead and look at the code and see what you see. Okay, welcome back. Hopefully you ran version 2. What was wrong with the first one is that it had nested if statements, but a 33% probability for each if statement. Here's the problem with that. If racehorse number 1 was not selected, then what you really are choosing is between two horses. So you have a 50% probability of selecting either racehorse 2 or racehorse 3. So what I'm hoping you found is that when you ran version 2, which was the fixed version, each horse did have a third of a chance. If that doesn't make sense, now that you have those two codes, go back and look at the codes and try it again and maybe test it 20 times and see what's up with that. And that's it. Hope that made sense.